Now we are going to discuss about our fifth note of wireless communication. The name of the fifth note is multiple antenna techniques. So more than one antenna, so that's why it is called as a multiple antenna techniques. In that multiple antenna techniques, Unit 5 is having objectives and outcomes. The Unit 5 objective is to illustrate the various multiple antenna system with the performance characteristics. What are the outcome of fifth unit? Design and implement the system with the transmit and receive the diversity and the MIMO systems, isn't it? So MIMO, the MIMO system, then spatial multiplexing, system model, pre-coding, beamforming, transmitter diversity, receiver diversity, channel state information, capacity in fading and non-fading channels. These are all the under the category of Unit 5. Now the MIMO system. Now we are going to discuss about the MIMO system, the first topic of fifth unit, by using multiple input, multiple output. So first M for M, multiple. So second I for input, third M for multiple. So fourth one is O for output. Multiple input and multiple output system. That's why it is simply called as MIMO system. The diversity gain mitigates the fading and increases coverages and improve the quality of services. That is why it is called as a QoS. Then the third point, multiplexing gain increases capacity and spectral efficiency with no additional power or a bandwidth expenditure. Then the finally, array gain the result in an increasing in an average ratio of SNR. That means signal to noise ratio. That is the main concept of the MIMO systems. The MIMO system diagram is shown in figure. We are going to discuss about the transmitter as well as the receiver side. The multiple antenna are used for a single user at both of the transmitter and receiver to exploit the spatial multiplexing and spatial diversity to increase the channel capacity and the data rate. It's like a main important point. Increasing the channel capacity and the data rate. That's why we are going to move to the MIMO systems. So MIMO, MIMO, multiple input, multiple output is implemented using the spatial multiplexing techniques. If it is improve the multiplexing gain in order to improve the data rate also, isn't it? So I am going to improve the gain means the data rate also increase. So I am going to decrease the gain in the sense it's not suitable for a MIMO system because if it is used to more than input, more than one input as well as the more than one output, isn't it? So our name itself, the meaning is there, MIMO, multiple input, multiple output. So in order to improve the data rate of the systems. Then another one is the spatial diversity and the spatial multiplexing. These are a very important two mark. What is the spatial diversity as well as the spatial multiplexing? Now we are going to discuss about the spatial diversity. The spatial diversity, the signal copies are transferred from the multiple antennas are received from more than one antenna. Once again, I repeated this. Signal copies are transferred from the multiple antennas or are received at a more than one antennas. So because of combination of one output, isn't it? So redundancy is provided by employing an array of antennas with a minimum separation of lambda by 2 between the neighboring antennas. So lambda by 2 is the wavelength of the spatial diversity. So what is the spatial multiplexing? It is a transmission technique in a MIMO wireless communication system. It's like a transmission technique. The technique is called as a spatial multiplexing in a MIMO systems. So MIMO wireless communication system to transmit a high data stream that is multiplexed into a several parallel streams. So the space dimension is reused or multiplexed more than one time. Then next, the basic structure of MIMO system. There are four structures. One is a single input and single output. Mainly it is called as a SISO, single input and single output systems. Then second one, single input and multiple output, SIMO. Then the third one is multiple input and single output, MISO. Then finally, the multiple input and multiple output, MIMO. The spatial multiplexing. We are going to discuss about the structure of the spatial multiplexing. The spatial multiplexing coming under the category of MIMO channels because of the multiple input, multiple output channels. The channel can be decomposed into a number of R parallel independent channels because of multiplexing gain. What is meant by gain? So gain in the sense we are going to calculate from the MIMO channels, isn't it? So that the MIMO channels including the spatial signaling as well as the spatial multiplexing. Then the principle we are going to use it as a spatial multiplexing as transmit the independent data signal from a different antennas to increase the throughput as well as the capacity. Then pre-coding. What is in the pre-coding? The pre-coding is defined as to decrease MUI multi-user interface and increase the data rate in the MIMO systems. Perform the transmit diversity. Third one, similar to a equalization. Fourth point, main difference is we need to optimize the pre-coder with the decoder. Finally, the pre-coding is defined as channel equalization and minimize channel errors. So, the pre-coding is a pre-processing technique which explores the transmit diversity by awaiting information streams. So, now we are going to discuss about the pre-coding diagram. So, the information source, the wireless communication, whatever may be the place, the information source as a input, so that it is applied to the demultiplexer stream. The demultiplexer in the sense, so if we are going to give it as a S1, S2, S3 as output of a demultiplexer. What is demultiplexer? One input or many output, isn't it? So the demultiplexer output is giving to, going to reach a modulation uh, block. That modulation block allows the output of a linear procedure, linear producer 1, linear producer 2, linear producer up to T. So that all of the output are the input of a directions and T coding of a output system of a pre-coding. Then the transmitter sent to the coded information to the receiver in order to get the prior knowledges of the channel from the pre-coding technique. The receiver is a matched filter that does not have a no the channel side information. This technique will reduce the corrupted effect of the communication channel. These are all the pre-codings. Then the pre-coding having the CSI technique, channel state information. The pre-processing, the types of processing at the transmitter which require the channel state information, that is simply called as a CSI. To obtain the CSI at the transmitter, the channel should be fixed at a large time period. So in this place we are going to use it as the channel state information of pre-coding. If the CSI is available at the transmitter end, the user can practically separate it by means of pre-equalization at the transmitter.